Hello. Today we're going to be looking at exploring circumference. Yesterday we did that sum, and we also talked a lot about pi. So today we're going to look at these circles and we're going to explore the circumference. First thing, let's review our two vocabulary words today. If we have a circle, the diameter is the distance across the circle through the center. Okay? So diameter, distance across the circle, and it has to go through the center. And the circumference is the distance around the circle. So if I were to measure all the way around the circle, that gives me the circumference. Now, what we were doing yesterday, we were taking a string, we were going around some circular objects and measuring, and we were finding the circumference. Now, and that was a good activity to explore and learn and talk about pi, but when we actually get down to needing precise measurements, you can see this is not 100% precise. It's not exact. I mean, it's close, but it's not exact. And then when I go to measure it, if my string has a little stretch, and this one does, that's another issue. So what we need is a formula, a mathematical formula to help us be precise. And they've actually given us that formula here. Notice that it is a proportional relationship, and the constant of proportionality is pi. So, we'll just write this out in words as well. Circumference equals, and this is the formula, pi times the diameter. So, if I have either the circumference or the diameter of a circle, then I can calculate and find the other piece. And that's exactly what I'm going to do. I have 5 circles here and some measurements I've been given so that I can complete this table. Now, for this case, what we're going to do is actually assign one of our values of pi. So if I want an exact answer, I just use the symbol pi because we know that pi is irrational, it repeats. It doesn't repeat, it doesn't end. It's just a decimal that continues forever. They use that to test computer systems. They have the computer systems try to calculate pi, and they see if it's a good computer system or if it's going to crash. So, little bonus there. A lot of times we'll use the approximation of 3.14 or 22/7. So for this case, now, depending on which value of pi that we use, our answers are going to be a little bit different. So let me show you why. This is, of course, Desmos, my favorite online calculator. 22/7 is more precise than just 3.14. And because it's more precise and it has more digits, the answer is going to be a little different. So I think what we'll do is just kind of explore and look at our numbers and see what's going to be best for us as we go. So right here I have the diameter, and then I have the circumference. And if I think about the circumference equals pi times the diameter. Now pi is a little more than 3. So let's just say if it's 3, okay? What you're doing here is you are multiplying by pi, so you're multiplying by 3 to get the circumference, which means that your circumference should always be more than your diameter, because when you multiply by 3, you're going to get a larger number, a larger value. So, just a quick way to kind of look and say, does that make sense? So our first one here, I guess I'll try to show my work. Over here I'll do circle A. So circumference equals pi times diameter. And I'm going to find the circumference by doing my diameter times pi. And that just looks weird. It should probably look like this, 3 pi instead. And I'm just going to pull up Desmos, and let's see here. 3 times 3.14, so there's one option. 3 times 22 over 7, okay. And what if I wrote these as fractions? Maybe that's going to, not feeling that one. Maybe this one? No. I think I'm just going to go with this 9.42. Notice it would be a little different. Even if you rounded here, it would be 9.43. But that's 1 cent difference, right? Because that would be 1/100th, which would be like 1 cent out of $1. It is a little different, but it's pretty close. And that's what happens when we're not dealing with exact numbers. Our answers may end up being close, but not exact. So I'm going to use this little symbol here that says approximately. And that just makes me feel a little better about it because I'm not using the exact answer. So I'm going to use that symbol. And this would be in centimeters because it is a distance, like a linear distance. And a distance is just measured in units. Area is measured in little squares or square units. Okay, so our next one is 10 for the diameter. So circumference is pi times diameter. That'll be 10, so that's the diameter, times pi. Now that's the exact answer, 10 pi, but I'm looking for, even though that's the exact answer, if I were going to, let's say, measure and cut something that was a length, then I would actually need, instead of pi, I would want it to be something like this, either 31.4, or let's see what we get when we do pi times 10. And again, a little bit different, not extremely different. Okay. So for my answer here, I'm going to put the circumference as approximately 31.4 centimeters. The next one, they made this one interesting because they're actually giving me the circumference. So what I'm going to have to do, I mean, I've been solving equations, but I'm going to solve this one a little differently because of the information I have. So I'm going to divide by pi, and that will give me my diameter. So 24 divided by pi, or the circumference divided by pi. Okay, 24 divided by pi. Okay, or 24 divided by 22 over 7. Okay, again, very similar. See what that looks like as a fraction. See, I'm actually preferring this maybe to the hundredths place, 7 and 64 hundredths. So that's what I'm going to leave it as. The diameter here is approximately 7.64 centimeters. Okay, then I have 18 for my circumference. I'm running out of room as usual. A bit. Circumference is pi times diameter. The circumference is 18. So let's divide each side by pi. So the diameter is going to equal, we'll have to do 18 divided by pi. I'm just going to do it both ways like I've been doing it. Whoops. Go to the next line. And then I'll see which representation I want to use. 18 divided by 22 over 7. That's a repeating decimal. Interesting. 18, whoops, divided by 3.14. Okay. Again, very similar. I think I'll go with this one, 5 and 73. I'm going to round here, 5 and 73 hundredths. Okay. Now sometimes you're told, let's say if this were an official test or something, you're told to use one of these for pi. You will be told, or sometimes it might say find the exact answer, so that's when you use the pi symbol. I forgot what it was. 5 73 hundredths. Approximately 5 73 hundredths. Okay. So when you're in a testing situation, you will have clarity. You won't have to make this decision of which one to use because you will be told either use 3.14 or 22/7 or find an exact answer, which means you use the pi symbol. So if I did exact here, circumference is pi times diameter. The diameter is 1. So circumference equals 1 pi, or which would be just pi. So I could have 1 pi here. If I did 1 times 3.14, that would be 3.14. Or if I did 1 times 22/7, that would be 22/7. So there's 3 answers there that are all very close to each other, but depending on which you're asked for in a testing situation, that's how you would decide. Okay, I better hurry up. The circumference of Earth, so distance around the Earth, is approximately 40,000 kilometers. If you made a circle of wire around the globe, okay, that is only 10 meters, and this is that in kilometers, longer than the circumference. Could a flea, a mouse, or even a person creep under it? So this is requiring us to really think about what we know about the circumference. If they are adding 10 meters longer than the circumference, so they're adding 10 to the circumference, okay? So they're adding 10 meters to the circumference. So let's just think about that. If they add 10 meters to the circumference, how does that change that distance? Okay. Circumference is the pi times the diameter. So if we're adding the 10, how does that change our distance there? How much space is that going to give us when we consider that? So 10 divided by 3.14. So that's a little over 3 for 3 meters. So for this situation, I'm just going to go ahead and say that is going to be, the diameter is approximately 3. So if we're thinking about, we have added 3 to the diameter, 3 meters. So a meter is, like roughly this distance. I'm trying to get in the camera. Okay. Anyway, yeah. Think of a meter stick. I'm trying to show you, but the camera's not working with me. Okay, so you've got a meter stick. That's how much you've added to the distance. Well, if I added that much to the distance of the diameter, okay, so the diameter is that much more, that means that on each side, because it's a circle, if I split that in half, okay, because I would need, to add like some here and some here, or actually kind of all the way around. But 1.5 meters is basically how much more you've added. So 1.5 meters is going to be plenty of space for a flea or a mouse or a person to get through. Now, this is kind of the extra bonus. So if you're struggling a little bit with that, you can just kind of let that bounce around in your head and think about it some more. It's just kind of a really interesting problem to consider. This is the next page, and it really goes back to what we did yesterday. We have the relationship between the circumference and the diameter. Here is our constant of proportionality, or our unit rate. This is illustrating that relationship, that the circumference is pi times the diameter. That is our unit rate, or our constant of proportionality. And we can use that to estimate the circumference of any circle. So let's say I go here to 3, and I find that on the line that's going to be, roughly a little more than 9, which would be correct. So go ahead and do your practice problems. Use your formula, and then I have another video that we will go over the practice problems with.